collision is said to occur when two bodies crash into each other, right? So that is a basic word or terminology's meaning according to what collision. But in actual practice or according to physics, the definition of collision states it is an event which occurs in an isolated system in which two or more colliding bodies exert relatively large force on each other in relatively small time. So that is the physical, according to physics, the definition of collision, but it generally means when two bodies are exerting force on each other because they just bounced into each other, right? Now, some examples of collision are when we play snooker or pool, the balls collide with each other, or when you hit nail from the hammer, that is also a sort of collision. When automobiles in accidents, they collide with each other. These are all sort of collisions. So collision is this whole phenomena. When we have to study about it, we study about all the forces involved in the process of collision. What happens to the energy of one body on the other body, or what is the effect of force applied by one body on the another body, right? So we have to take all sort of energy conservation and momentum conservation into account. So this conversion is basically governed by two major laws, that is law of conservation of energy and law of conservation of linear momentum, right? These are two governing factors for any sort of collision. So what we have done is we have categorized collisions into two major parts. One is called elastic collisions and another is called inelastic collision, right? One is elastic collision and another one is inelastic collision. So what is the basic difference or meaning of these two words? Inelastic collision. Now, see, consider two snooker balls or two marbles or two carom sides. So when you take two balls or snooker balls towards each other and throw them with some velocity, while after colliding, they will definitely go back to their original position, maybe more than that, right? So they have transferred their energy to each other. That sort of collisions are called elastic collision. So elastic collision is something, according to definition, elastic collision is that collision in which kinetic energy is conserved, while inelastic collision is that collision in which kinetic energy is not conserved. For example, I have see, I'll give you the example, but in actual practice, perfectly elastic collision and perfectly inelastic collision do not ever occur because there is definitely some sort of loss of energy everywhere. So elastic collision, as per the definition, it should not have any loss in kinetic energy. But see, consider a tennis ball or a Costco ball or a marble or golf ball at this height, and I drop it. It will bounce back after hitting the ground. But if the collision, that collision is supposed to be elastic, then there should not be any loss in kinetic energy, right? So the ball must bounce back to the original height. But that never happens. Ball remains at a height which is less than the original height. That means some sort of kinetic energy has been lost while this collision happened. So that is why perfectly elastic collision never happens, because there is definitely some loss of energy. Moreover, inelastic collisions are those collisions in which kinetic energy is not conserved. For example, I make up a ball of clay and I drop it from this height. What will happen? It will not even bounce from the ground. It will stick to the ground, right? So that sort of collision where kinetic energy is lost, in actual practice or in perfectly inelastic collision, kinetic energy should completely lost, but that is also not the case. That doesn't happen because when clay will hit the ground, some part of its energy will get converted into sound energy. So yeah, energy is not completely getting transferred into or getting lost, right? Some other energy is created. So what are the main difference between elastic and inelastic collision before I move on to the examples? Or let us just first write two examples for elastic collision. Write down one, you can say two snooker balls hitting each other, that is elastic collision because they'll bounce back, and other one is when you throw a golf ball from some height, that is also kind of elastic collision because golf ball is something which regains 60 to 70% of its original height. That is the maximum any ball can attain. So that are examples of elastic collision. And in inelastic collision, consider I fire a bullet or I fire an arrow, okay, on a target. Now the bullet gets, suppose the target is wooden block, the bullet gets embedded in the wooden block and both of them are moving with a common velocity. That is inelastic collision, because bullet did not came back after hitting the wooden block, right? So same is the case with arrow. When arrow is given some kinetic energy, it is thrown to the wooden block, that is target, it will get embedded into it and both will move with further with some or more velocity, but it is supposed to come back. So both of these examples fall into inelastic collision. So three major difference or the main points of elastic and inelastic collision is that this obeys law of conservation of, I'll write law of conservation of energy, obeys law of conservation of linear momentum, and it obeys law of conservation of kinetic energy. These are the key points of elastic collision, whereas in inelastic collision it obeys, I write complete, obeys law of conservation of, same ways energy, yes, law of conservation of energy is obeyed because this is a universal law, you can't mess with it. Law of conservation of energy is obeyed everywhere, there is no flaw in it. Then again law of conservation of linear momentum is also followed, linear momentum. So this happens in case of inelastic, but the law of conservation of kinetic energy is not followed. So it, instead of not follows here, I will draw it does not obey law of conservation of kinetic energy. So these are 3 points, main points of elastic and inelastic collision.